Hi, this is Mr. Goma, and in this video, we'll talk about what happens to ionic compounds when they're dissolved in water. So remember, ionic compounds contain a metal and a nonmetal, sometimes a metal and a polyatomic ion, and of course they're comprised of ions. So within the neutral compound overall are positively and negatively charged ions. Well, the first thing to note is that ionic compounds dissociate in water. Well, what would that look like? Suppose we have a compound like calcium chloride, CaCl2. This compound here is not going to stay together when it goes into water. It's going to separate out into its component ions. So within calcium chloride, we're going to have a Ca2 plus ion. We're going to have a chloride ion and another chloride ion. Those two chlorides and one calcium ion are represented here. So what's going to happen when they go into solution? Well, if we had a beaker here and we were going to put the calcium chloride into solution, and here's the water, I'll emit the water molecules, what we're going to end up with is a Ca2 plus ion and two chloride ions. All right? So one important thing to notice is that we get more ions than we have units that we originally started with. For every 1 unit of CaCl2, we end up with 3 total ions. We end up with 1 calcium ion and 2 chloride ions. So this is important to notice for concentration as well. So for example, if we start out with 1 molar calcium chloride, we're going to end up still with 1 molar Ca2 plus, but we're going to end up with 2 molar chloride, 2 molar Cl minus. That's because for every 1 calcium chloride, we end up with 2 chloride ions. All right, this is different than what would happen with molecular compounds like sugar. So let's suppose we have something like a sugar. It says C6H12O6, that's glucose. If this goes into water here, and we have a whole big massive chunk of glucose, it will separate out into the ions, it will separate out into the molecules, but each of these molecules will be together. So if we have 2 of these, then what we would have is one C6H12O6 and maybe another C6H12O6. So the different molecules are going to separate out, but the individual atoms are going to stay within the molecule. So we don't get the atoms separating out. Here we do get the ions separating out. Okay, let's do one more example. So basically, molecular compounds do not dissociate, but ionic compounds do dissociate. So let's do another example with one more type of ionic compound, this one with a polyatomic ion. And with this one here, let's do magnesium nitrate. All right, so magnesium has a 2+ charge, just like the calcium does. They're both in group 2 of the periodic table. Nitrate is a very common polyatomic ion. It has a 1- charge. So we need 2 1- charges to balance out the 2+ charge. So let's put this into water here, okay? So they're gonna dissociate into their ion. So of course we have a magnesium 2+ ion, but the nitrate stays together. It's a polyatomic ion. The nitrates do not dissociate. Polyatomic ions don't separate themselves out. They're going to be like that. So we would end up with, again, if we had 1 molar magnesium nitrate, we'd end up with 1 molar Mg2+ in solution, but 2 molar NO3 minus. And the NO3s, the nitrates, are not going to dissociate further. They will separate out from the compound, but they're not going to break apart into individual atoms. Well, hope this helps. Good luck with your problems.